Hello and welcome to The Conversation Weekly.
This week, India and Pakistan have been sweltering under an unprecedented heatwave, but scientists predict worse may be to come.
If we look at climate projections for the region, we are anticipating seeing a lot more days over 40, over 45 degrees Celsius.
And after India banned wheat exports in early May due to the high temperatures, we find out how vulnerable crops and farmers are to extreme heat.
Heat did play an adverse impact on the productivity of wheat. If I go by the figures, the productivity has gone down by 12 to 18%.
I'm Dan Marino in San Francisco.
And I'm Gemma Ware in London. You're listening to The Conversation Weekly, the world explained by experts. A couple of days ago, I called up Shruti Bhogal. All right. Is it the red button? The numbers are going up?
Yes.
Great. Okay. So welcome to the podcast, Shruti. You're in Punjab right now. So tell us, how hot is it today?
Gemma, it's really scorching hot today. The temperature is somewhere around 109 degrees Fahrenheit, around 42 degrees Celsius. So generally this month of the year is hot, but nothing as hot as this has happened in the past century or so. So it's quite hot here.
Shruti is an expert in agricultural economics based in Punjab, a state in northern India. She's just finished working as a research associate for a project on agricultural sustainability in Punjab, run by the University of Cambridge in the UK. And right now, she's thinking about how to keep cool.
We are barely going out. We're going out only for necessary stuff. The children are staying home. The schools have reduced the number of working hours. And now, from today onwards, the schools have been shut. And other than that, if you go step out in the afternoon, it's so hot and you barely see any traffic on the road. We are, almost dependent on air conditioning. We're trying to keep ourselves hydrated. But the bad part is that Punjab is also facing, power shortage. So even the luxury of air conditioning is also not very effective because there's shortage of power. So the weather gods have not been very kind to us.
Are you in the city?
Yeah, I am based out of Ludhiana, which is a city in Punjab, which is the most populated city of Punjab.
And do you think it's harder to keep cool in the cities or in the rural areas?
It's definitely a little cooler in the rural areas because the rural areas in Punjab are mostly, farmlands. Because of the irrigation, the soil would be a little moist and, the temperature would be a degree or two lesser than the city. And in city, because there's so much construction going on and the, cities are filled with buildings and everything, the temperatures and the winds, etc., are not very conducive here. So the temperatures are higher in the city part as compared to the rural areas.
Have you ever experienced a heat wave like this before?
Oh, no. Not like this. Not in my lifetime. I haven't experienced such a heat.
South Asia is under the grip of a record heat wave.
Over the weekend, a temperature of 49.2 degrees Celsius was recorded in the capital, Delhi.
Karachi is facing an intense heat wave. Doctors have urged the people to brace themselves as the temperatures might touch 50 degrees Celsius.
That's crazy hot. I think the hottest temperature I ever felt was in Death Valley, California, and somewhere around 115 Fahrenheit, which is like 46 point something Celsius. Gemma, what's the hottest you've ever felt?
Well, I think mine was low 40s Celsius once when I was in Hanoi in Vietnam, and it was super humid and really, really sticky. But 49, 50, 51, that's just horrible.
It is. And while that was record-breaking for Delhi, India has actually recorded an even higher temperature of 51 degrees Celsius back in May 2016. Pakistan has hit 53.7 in 2017. But one of the things the experts we've been talking to for this episode have repeatedly pointed out is that fixating on individual high temperatures doesn't give you the full picture when you're thinking about heat waves. What's made India and Pakistan's current heat wave so remarkable is when it started and how long it's lasted.
The persistence of the heat is really remarkable.
This is Andrew King. He's a lecturer in climate science at the University of Melbourne in Australia. He studies extreme weather and climate change.
It's been extremely long. We've had extreme heat through March, April, and now much of May as well. So we're talking about over 2 months of really extreme high temperatures. temperatures well in excess of 40 degrees quite frequently, and more recently up to about 50 degrees Celsius in the northwest of India and the southeast of Pakistan. The heat has really been exceptional since March. Many regions saw their hottest Marches on record, and that we saw again through April.
So just to put this in perspective for the US listeners out there, 40 degrees Celsius is 103 Fahrenheit, and 50 degrees Celsius is 122 degrees Fahrenheit. So this is like crushingly hot. Don't go outside because you might get heat stroke level temperatures, right?
Yeah, so it's really insufferable heat, and it's occurring in a region where many more people work outside than in places like the US or Australia. So people can't really escape indoors, turn the air conditioning on.
I sometimes feel dizzy because of the heat. A little while ago, I was about to collapse. It's so hot that I can barely speak.
More than a dozen people have died in India in the past 2 months due to a severe heat wave. Experts blame high temperatures driven by climate change.
Many more people are really feeling the effects of the heat for longer.
And how does this compare to, say, a normal year?
So normally March, April, May, it's warming up, and May it's quite common to experience heat waves, especially in northwestern India and eastern Pakistan. May is normally hottest time of year ahead of the monsoon, and temperatures exceeding 40 degrees are not uncommon in that region, but temperatures in the high 40s, around 50 degrees, are uncommon. These heat waves are hotter than they usually are in this region at this time of year.
So what's the weather pattern that's producing this heat wave?
We have seen kind of high pressure, very dry conditions over the region for the last few months, and that's really what has caused the heat wave, because it's suppressed any rain that tends to bring cooler weather. There have been some breaks. It depends where you are exactly in India, and there have been occasional spells of rain which have brought cooler temperatures, but it's been predominantly just having dry conditions under high pressure, and we just haven't seen as many of those breaks. I mean, we see this around the world when we have weather patterns that kind of stay in place for longer than normal. We tend to have problems in different regions. We see this quite often in the US, where weather systems kind of get locked in place, and then you get floods in one region and heat waves in another region.
Let's start talking to what's driving this heat wave, what's causing it. And I think the first thing most people think of when they hear about an extreme heat wave is climate change. And the way to connect climate change to a single extreme weather event is through something called an attribution study. Attribution studies are a way for scientists to see how much of an effect climate change had on a single extreme weather event. So has anyone done an attribution study on this heat wave yet?
Yeah, actually, an attribution study just came out a couple of days ago from the UK Met Office, and it found a very, very clear climate change influence.
Record-breaking heat waves in northwest India and Pakistan are 100 times more likely because of climate change. That's according to a Met Office study. Temperatures. I
actually saw that study, and they were saying that climate change increased the chances of this by about 100-fold. So this usually would have been, a once in 300-year heat wave. Now it's estimated to be a once in 3-year heat wave. Are you surprised by that?
If we look at prolonged spells of heat over large areas, often we do find climate change signals 100-fold increase or even more. There was a study on a Siberian heat wave a few years ago that had a really, really large number increase in likelihood. And we've had other ones in Australia where we found the heat would have been virtually impossible without climate change. So it's definitely alarming, but it's not too surprising.
Let's look at kind of the general trends of South Asia. How does this heat wave fit into what's been happening over the last decade or two as climate change has really started to affect weather patterns?
So we've seen some really severe heat wave events in recent years in this region. It's worse, though, than what we've seen recently, especially in terms of its duration. In general, in this region, we're seeing temperatures rising, but if we look at the most extreme heatwave temperatures, we haven't seen an increase up until now. It's more that the heatwaves have become a bit more frequent.
Do we know why there's been an increase in frequency, but not really intensity?
We know that we influence our climate through emitting greenhouse gases and increasing concentrations of greenhouse gases in the atmosphere, and that's warming the planet. But in this region as well, we've influenced the local climate in other ways through emitting aerosols. These are little particles basically linked to air pollution. And we've also influenced the local climate of this region through irrigation. So both the aerosols and the irrigation have kind of damped some of the warming in this region, especially in extreme high temperatures in the last few decades. But in the next few decades, we expect those effects to weaken slightly and to have a slightly accelerated increase in extreme high temperatures.
What are the mechanisms behind this? Like, how are air pollution and irrigation actually dampening temperatures?
If we have more air pollution, it could be through increased population, more kind of industrial activity, then we have more particles in the atmosphere, and those particles reflect the sunlight before it reaches the surface. So it just has a slight cooling effect.
Okay.
With irrigation, you've got more of the surface covered in water, so more evaporation, which has a slight cooling effect as well. If we weren't emitting aerosols in this region to the same extent, and we weren't increasing the irrigation in this region to the same extent, and we were still having the greenhouse gas emissions we do, then we would have higher temperatures in this region than we currently do. In some locations, it's actually decreased. The highest temperature you would see in a given year, the trend in that has fallen in a few areas of India. But without the aerosol and the irrigation effects, that wouldn't have happened. It would have been an increase. We know if we look at climate projections for the region, we see much hotter heat waves, more frequent and longer heat waves.
How much hotter are we talking about here?
It depends on the exact locations, but we are anticipating seeing a lot more days over 40, over 45 degrees Celsius. A lot of the difference between models is in part to do with how models handle aerosols, because some models handle them differently to others. So that has a bit of an influence on heatwave projections in this region, where we're anticipating kind of a big drop in aerosol levels. In some parts of the world, we have seen big reductions in air pollution. And in the US and in Europe, this kind of came a few decades ago. But in East and South Asia, it hasn't really happened yet. We're hopefully peaking.
Well, aerosols are essentially another word for air pollution, right? And decreasing air pollution, getting rid of aerosols, is certainly going to be good for people's health. This is kind of a double-edged sword, huh?
Yeah, so air pollution is still having major effects in India and also in East Asia. We've seen recent news around the fact that we see millions of excess deaths in India due to air pollution.
Over 1.67 million people have died last year. As for alarming levels of pollution, the main reason behind these deaths...
So reducing air pollution would have really major benefits, of course. One of the unfortunate side effects, though, of reducing air pollution is it does increase the temperatures during heat events.
If you were to, snap your fingers and remove all aerosols from northern India right now, are we talking about a 2-degree jump in this heat wave?
It's quite hard to quantify. It would be maybe not quite as much as that, but it would be a notable increase.
That is just really grim news, that if the region succeeds in reducing its air pollution levels and keeping people a bit healthier in their lungs, which it absolutely needs to do, it could actually make heat waves even worse.
Stuck between a rock and a hard place, in like a really sad sense of the phrase. All of these projections are based on climate models, which can help people understand what's going to happen in the future. But other researchers have been looking backwards at heat waves that have happened in the past.
My name is Dr. Alan Kennedy Asser. I am based at the University of Bristol in the UK, and I also work currently at the moment as an embedded researcher for an organisation called Climate Northern Ireland. So you might be able to hear from my accent, that's where I'm from. originally.
Alan's research focuses on heat extremes and their impacts on people. His work is mainly in the UK, but he's just published a new study on the results of a hunt for the world's most extreme heat waves over the past 60 years. A starting point of this research, which was led by Alan's colleague Vicky Thompson at Bristol, was how do you define a heat wave? And in particular, how do you measure how extreme a heat wave is?
We can think about that in two ways. It could be in what we would describe as absolute terms. So it would be temperatures above a specified number. So let's say 35 degrees Celsius. Now, above 35 degrees Celsius is a pretty major heat wave for Northern Ireland. This is unheard of for Northern Ireland. But for somewhere like India, 35 degrees Celsius, you probably wouldn't class as a heat wave. That's just sort of normal summer heat. And so using an absolute number can have limitations. So the other option is that you do it in some sort of relative way based upon what you would normally expect for an area. So if we think about what the temperatures are like during a typical summer, you will have your average temperature and you'll have variability around that. You can measure the variability statistically using like the standard deviation. And so we decided we wanted to look at our heat waves in terms of how many standard deviations they were outside of normal. So how variable they were compared to normal.
Okay, Dan, hold up a minute here. For people like me who stopped studying maths and statistics a very long time ago, I need some help. So what is standard deviation?
Okay, so standard deviation is a statistical tool that helps to understand two things: how unusual a single event is compared to the average, and also how variable a certain data set is.
Still don't get it.
Okay, so I'll break it down into the unusual thing and the variability thing. The best way to explain this is to imagine you're slowly pouring sand out of a bucket, right? It'll form a little pile that is tallest directly below the bucket and slopes down as you move further away from the spout. It'll form a sort of round-topped mountain, which looks like what statisticians call the bell curve. The tallest part of the sand pile is the mean or the average, and standard deviations are a measure of how far away something is from the mean. So imagine a single grain of sand falling. Chances are pretty good it's going to stay close to the bucket, or in statistical terms, within one standard deviation. That's why the pile is tallest there.
So that's the majority of the sand that's going to land around the mean, the average at the top of our pile. But some of it will actually land on the slopes or even right at the bottom of this pile. What about that sand?
As you go farther away from the mean, there's less chance that a piece of sand will land there. Within 2 standard deviations, you're going to include 95% of all the sand, and the chance of a piece of sand going farther than that just goes down. At 3 standard deviations, it's even smaller. 4 standard deviations, it's really tiny, but you still will find some sand like way away from the bucket.
Okay, I think I understand the distance from the average, but what about variability?
So there's variability in all data sets, and the standard deviation is designed to deal with this. So in our example, imagine it's a little bit windy. The sand is going to form a much wider pile, but one standard deviation is going to still include just as much sand as it would if it wasn't windy. So to do that, it has to be a little wider, a little farther from the mean. The same goes for 2 and 3 standard deviations. Because it's windy, sand has a better chance of falling farther away, so the standard deviations are bigger.
All right, Dan, thank you. I think I now get it. So standard deviation is a really good way of understanding how a particular event or even a piece of sand, how close it is to the average, and also how it might be affected by different variables. So let's go back to Alan and his study and the way he was using standard deviation. What were he and his colleagues actually trying to do?
So Alan and his team were motivated by a big heat wave that hit Western Canada in 2021.
An extreme heat wave is sweeping across Western Canada. The unprecedented heat smashed Canada's temperature record when the mercury hit 49 degrees Celsius.
They wanted to find out how extreme this heat wave really was compared to other extreme heat waves around the world. But the first thing they needed to do was establish a mean temperature for each region. They called that the baseline.
For us, the way we did our baseline was we found the hottest month of the year for a given region, and we took the 1 month either side of that. So we took a 3-month period, and then we used like a kind of moving baseline from which to calculate the standard deviation and the mean.
And they didn't just do this calculation once. They looked at many heat waves going all the way back to the 1960s. And to produce a baseline for each heat wave, they looked at the 10 years prior in that particular place.
The main data set we used for our baseline was a reanalysis data set called ERA5. That's a European data set. We compared it as well to a Japanese reanalysis data set. And so both of those collectively started, I think, from 1958. So that was when we started the baseline. So our first 10-year period went from 1958 to 1968. For 1968, we looked at the data for 1958 to 1967. And then we would progress a year. So for 1969, we would look at 1958 to 1968 and so on. So we had this moving window, because otherwise we would basically find when we did the analysis that lots of major heat waves occurred in the last 10 years of the record, because we'd be comparing to
warming.
Exactly. So it sort of adjusts for the overall long-term warming trend.
Okay, so that's a good way of teasing apart general warming trends from actual extreme heat wave events, right?
Exactly, yeah. The reason I think that's important, again, coming back to this idea of a relative heat wave in terms of the variability, if we look very long into the future, say, in a climate simulation with a high warming scenario, as the baseline temperature warms, if you had a fixed threshold for your heat wave definition, you will just naturally see more heat waves occurring. And is it truly a heat wave if that just becomes normal? I'm not saying that's a good thing that happens, but it's not really a heat wave anymore. It's just the new normal. So we tried to adjust for that.
Okay, so a fantastically clever way of looking at heat waves you guys came up with. What was the question you were trying to ask with this approach?
So the question was that heat wave in Western Canada in June last year totally unprecedented in the sort of historical record? And we found that it was in the top 10 most extreme heat waves that had occurred, but it wasn't the most extreme, head and shoulders above the rest. It was comparable to other major heat waves that we found in this data set.
What were kind of some of the heat waves that stood out?
The biggest heat wave that we found in the record was actually one that occurred in the Western Pacific, so parts of Philippines and into Indonesia, and that occurred in 1998. So thinking about, again, our definition of these heat waves are in terms of the normal variability. These are quite low-lying areas right on the equator, at the edge of an ocean. Like the variability is not typically that large. So this large heat wave was maybe 5 or 6 degrees outside of normal, which if you were to have 5 or 6 degrees of a heat wave in Canada, that's quite normal. So actually 5 degrees is a big increase. And we still think it could have significant impacts. For example, if there's, marine ecosystems and coral reefs, we know that they're very, very sensitive to slight changes in temperatures. And that heat wave, we think, was associated with a large El Nino, which occurred in 1998. So we think those two things are linked.
How many standard deviations was this one? And how many standard deviations was the Canadian one?
So the most extreme one there in the Western Pacific was just over 5 standard deviations. The Western Canada heat wave was about 4.1 standard deviations.
So the Canadian one is still very high.
Yes, yeah, it's still very high. But yes, of the major heat waves we identified in the paper, I think we used a cutoff of 4 standard deviations, and we put any events that were bigger than that in, and it gave us about 10 events around the world. And the locations of those range from Western Canada and Alaska. We had one in Florida, one in Peru, a couple in Brazil, and then this one in the Western Pacific.
When you say anything 4 standard deviations and above, we're talking, based on random chance, like very, 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 very low percentage of this should happen.
Yes, yeah. But crucially, what we would argue from having done this analysis is that these events aren't unprecedented. They do seem to occur in the record. So, and that's to be expected, because that's how kind of random chance works. But it wasn't like this heat wave that occurred last year was like the Earth going over a tipping point and hitting this new sort of state that had never been seen before.
One place you didn't just mention in your list of places that have had an extreme heat wave was South Asia, India, Pakistan. So what about that region? Were you surprised to not find one there?
Yeah, that's a very good point. And it was something that we worked with the conversation with to write an article about just as the paper came out. So we looked at our numbers, because the numbers didn't immediately stand out for India and Pakistan. And what we found was that the largest heat waves in these records that we looked at for India and Pakistan were sitting maybe around 2 to 2.5 standard deviations. So not anywhere near as extreme as some of the other heat waves around the world.
Yeah.
That, of course, that said, when you actually do the calculations of what 2.5 standard deviations looks like above the already sort of warm month temperature in India
Sure.
And Pakistan, it's one of the hottest places on Earth. But at the same time, it suggests that if we've had heat waves that were 3, 4, even 5 standard deviations occurring elsewhere in the world, somewhere potentially like India or Pakistan that hasn't seen a heat wave that extreme could quite conceivably experience one, even without further anthropogenic warming. Like there could be some seriously big heat waves down the line.
Like the random chance just seems to point that this could happen. So if that happens in a place that's already naturally incredibly hot, bad things, right?
Exactly, yeah. So I suppose one thing that's makes the comparison of what we did in the paper a little difficult, say, compared to what you would read in a news article or a weather forecast, is that we've been looking at relatively large regions. And when you average over a large region, you'll bring down, what the peak temperature looks like. So, for example, going back just briefly to Canada, the record was set, I think, at 49.6 degrees Celsius. When we average over the entire region, the maximum temperature comes out at maybe 45 degrees Celsius. So it's about 5 degrees less. So when we looked then at India, which is what we did in this conversation article, and sort of said, well, conceivably, you could have a 4 standard deviation or 5 standard deviation even event occurring in India. That would be average temperatures over large regions of over 50 degrees Celsius. So,
wow.
Those sorts of temperatures are seen in India and are recorded at weather stations, but that's on a very small sort of local scale, not the average. And I think it's very important to stress that although we argue that it's conceivable that regions that haven't experienced these large standard deviation events could experience in the future, this isn't a method of forecasting. We're not saying that it's due in the next X number of years, but it's just as much as anything else to sort of raise the alarm bells that it seems conceivably possible. I think it's just really important to try and use this as a conversation starter to make people think about climate adaptation and how they can make themselves and if they're a policymaker, make their populations kind of more resilient, because these sorts of events can and probably will happen at some point in the future.
Talking with Alan, I was really struck by a point he made about local variability. What's really hot in some parts of the world is pretty normal for others, but that doesn't mean an extreme heat wave, say in the UK, that only goes to 42, 43 degrees, isn't extreme. What's important is how much the heat goes above average in a particular region. If it got super hot in the UK where you are, Gemma, the infrastructure isn't built to handle it. You're just not going to be able to cope, no matter what the temperature is compared to somewhere else that's much hotter.
Yeah, it's about whether you hit the extremes of what you're used to. And that's what's been happening in India and Pakistan. They're used to extreme heat, but not this much extreme heat. And actually, the infrastructure is being affected in India and Pakistan. Remember, Shruti Bhogal told me that things were grinding to a halt in the city of Ludhiana, where she's based. There were fuel shortages and power blackouts and even the schools shutting down. Now, her research focuses on the agricultural sector. And so I actually asked her about this, about what's happening in Punjab and how the heat wave has been affecting farmers there.
It has already been established that this heat is having adverse effects on the agricultural production. For example, in Punjab, the entire agricultural period is divided into 2 main cycles or 2 main seasons. That is a winter season and there's a summer season. The winter season, we have a wheat crop, and for the summer season, we have paddy or rice crop.
When does the winter season start?
So the winter season, the sowing actually starts in somewhere in the month of October, November, early November, late October. And the harvesting happens somewhere in middle of April. So generally, April month is supposed to be hot, like warm. Average temperature would be around 30 degrees Celsius. That will be the maximum temperature. And that kind of temperature is supposed to be good for wheat, as it helps in proper ripening of the crop. But due to the changing climate, this pattern has shifted. Like now it became really hot in March and April. This time, the average temperature recorded in March was around 113 degrees Fahrenheit or 45 degrees Celsius. So that kind of temperature really affected the production of wheat crop. And of course, it impacted the income of the farmers and the state revenues as well. If I go by the figures, the productivity has gone down by 12 to 18%. So heat did play an adverse impact on the productivity of wheat. Not only the crops, it has affected the dairy sector as well. Because, in the summer months, anyways, the milk production goes down because of the heat. And this is impacting the prices. So in other words, the heat stress or the climate change has not been conducive both for producers and the consumers.
Okay, so the wheat crop has already been affected, but what's the outlook for the next few months for the summer crop of rice in the paddy fields?
Coming season of paddy, it's going to be even more concerning because I said the heat stress is anyways going to reduce the productivity of the crop, especially at the phase of germination in the month of June. On top of it, there's going to be water stress because the rains are expected to be erratic, and to meet the water requirements, farmers are going to be pumping out more water, which is anyways established to be an unsustainable practice. And thirdly, we are facing power shortages. So the farmers are going to experience a further high farm cost. Why? Because they would need to irrigate their fields, and they would be using substitute measures like diesel engines, the generators to pump out water. So the farm expenditures are going to go high. In other words, the farm income, the state income, the exports, the production, all is going to be affected.
You said that farmers in Punjab grow two main crops, so wheat in the winter and then rice in the summer. Has this reliance on two main crops made farmers more vulnerable to the heatwave?
Yes, it has. You have every scientific evidence that tells you that monoculture, that is growing one crop in one season, is not sustainable.
Another quick explainer here on monoculture. You may have heard that monoculture is really bad for soils and biodiversity, but there are some good reasons to farm this way.
There are. So growing one crop at a time means that farmers can use machinery and farming techniques that are specifically adapted to that particular crop. And this can mean they can increase their productivity and the yield that they get from the fields. But it can also make them really vulnerable. So it makes them overly reliant on the success of this one crop. And then if their harvest is hit by something like, extreme heat, farmers risk losing a proportion of their income.
It's basically like putting all the eggs in one basket.
Exactly, and that is the problem with growing just wheat in the winter and then just paddy in the summer. So let's go back to Shruti.
So as per a report by NASA, it suggests that the northwestern region, which includes Punjab, Haryana and Rajasthan, it's headed towards desertification. So this heat stress is not going to be very conducive for paddy. Paddy is a water-intensive crop. But in addition to that, there is going to be water stress as well. Climate change does not only include heat stress, it also includes, erratic rainfall. So this year, the Met Department is expecting the monsoons to come a week prior. And historically, if you see, whenever the monsoons have come a week prior or prior to the usual dates, those seasons have experienced shortfall or erratic rainfall or droughts as well. But the thing is, had there been little more diversification, had there been crops which required lesser water, and on top of it, crops which also were heat tolerant, for example, maize, cotton, millets, the concern of food insecurity, the concern of agricultural unsustainability could have been easily dealt with. But this is not happening for Punjab.
If there are all these risks involved, then why are farmers still growing mainly wheat and rice?
The answer to this goes back to the time of Green Revolution. So when Green Revolution came to the country in the 1965, it brought in not only high-yielding varieties of seeds, but the government supported and facilitated it with a minimum support price policy, which covers its cost of farming, and assured public procurement. Prior to this Green Revolution, farmers had a diversified cropping pattern. But because of the need to make the country self-sufficient, because we were going through a rough patch, more focus was laid on wheat and rice. So therefore, all the schemes and all the policies went towards promoting this crop. Time passed, we did achieve food self-sufficiency. We are now exporting food as well. But the policies have not evolved yet. Now, over a period of time, only 2 to 3 crops, mainly wheat and paddy, are being procured. So farmers have no incentive and they have a lot of risk involved if they switch to any other crop. That's why this diversification is also not being picked up by the farmers. Obviously, wheat and paddy is a safer bet for them. So that's why they're not diversifying.
As part of your work, you're actually trying to get farmers to grow alternative crops, not to rely so much on wheat and paddy rice. Tell us what you've been doing to do that.
Gemma, this project Digress by University of Cambridge, which is a GCRF-funded project, was more about agricultural sustainability in Punjab. So we in Punjab were mainly focusing on encouraging farmers to adopt water-efficient agricultural practices. So these practices include not only crop diversification, but also other practices like smart soil moisture sensors, using machinery and equipment like laser land leveler, etc. So we have undertaken a lot of field interventions where we've interacted with farmers, influenced them to bring about a behavioral change, though it was a very challenging task. However, I would like to point out here that wheat is not a very problematic area for Punjab because the kind of climatic conditions we have here are perfectly suitable to wheat, and wheat does not even require as much water as paddy.
It sounds like the paddy fields and all the water that they require to grow rice is the main problem. Is the Punjab state government also trying to get farmers to diversify away from rice?
So what the Punjab government or the state government has been focusing for over 5 decades now is on diversifying area away from paddy. So the other crops the state government is looking towards is maize, it's looking towards cotton, it's looking towards horticulture, that is vegetables and fruits, agroforestry, there's a tree called poplar tree. But in the list of the crops that the state is mentioning, millets is not being mentioned there. But the farmers are saying we are not growing paddy at all. They're choosing to grow millets themselves.
Why are they doing that?
That's a very interesting topic. In fact, we had a team of archaeologists in our particular program, Dr. Cameron Petrie and Dr. Adam Green from University of Cambridge. So their archaeological studies show us that, millets date back to as far as 3rd millennial BC. Even before the cities of the Indus civilization, millets were being grown 3,000 to 4,000 years ago as well, because these were primarily safer in the sense they were heat tolerant and they did not require a lot of water. Even if coming down the timeline 100 years ago, there are reports that show that there was a lot of diversification and millets were part of it. But over a period of time, this area has been reducing.
Of the farmers that are deciding to try millet as well as wheat or paddy, what kind of farmers are they who are experimenting with this crop?
We got in touch with a particular farmer who lives near my city. So this farmer that I was talking to is a small farmer and he's got into millets. He's experimented, he's risked into millet, but obviously he's not put all his land under millet. He's put some part of his land under millet and he's got into a collective. He's collecting the people in his village and they're growing millets collectively. They're further processing it and they're exporting it as well. These are the young farmers who are more informed, who are ready to take risks and who have innovative things. I mean, they're just not producing millet as a raw produce and they're just selling in the market. They're further adding value to it.
What role do you think the government has to play in persuading farmers to make sustainable choices in what crops they plant in the face of extreme weather events?
Setting up the basic infrastructure, creating a conducive environment, and working on agricultural sustainable practices. This is all the responsibility of the government. There was a report by UN which said that by the year 2050, they're expecting a 60% increase in the food demand. And climate is becoming more erratic and more unexpected. So given that by the passing time, we're going to be requiring more food, but the climate is going to be adding detrimental to the food production. So the basic responsibility of the government is not only to stock food and distribute it to its poor or maybe, monitor the prices. The basic responsibility of government is to make agriculture sustainable. And that only government can do. It can be facilitated for the private players, but the key responsibility is of the government.
India banned wheat exports on Saturday as a scorching heatwave slashed output and domestic prices hit a record high.
In mid-May, India banned exports of wheat. So it's clearly thinking about this in terms of supply and demand of actual crops. But what you're saying is that actually it's got to have a much longer term plan and think about this in 10, 20, 30 years ahead.
Yes, there are 15 other countries who've banned exports of different products. Different countries, what they're currently trying to do is just patchwork. And it is okay now because, we were just taken aback, the Ukraine war and the heat stress, everything is clubbed together. And we currently are doing patchworks. But this is not going to work further. The next season or the next year, if you say that we're still doing patchwork, it's not acceptable.
Since we recorded the interviews for this episode, the weather has changed a bit and temperatures have fallen, but in some parts of northeast India and neighboring Bangladesh, thunderstorms have brought severe flooding.
The worst flooding in remote areas of India and Bangladesh in nearly 2 decades. Many millions are displaced after torrential rain submerged swaths of farmland.
You can read more stories about the India and Pakistan heatwave, including articles by Shruti, Andrew and Alan on The Conversation. We'll put some links to those in the show notes.
Before we go, here's Neeta Sarl from The Conversation in Toronto, who's just released the latest season of her podcast, Don't Call Me Resilient.
Hi, I'm Neeta Sarl. Welcome to Don't Call Me Resilient, where we delve into systemic racism and the ways it permeates our everyday lives. This season, we take a look at our responses to some of the most charged stories of the past 2 years and what has and hasn't changed. We'll tap into our collective despondence, but we'll also celebrate refusal and resistance.
So what are you going to do, settler allies? Are you going to give us the land back, the political agency to sort of begin anew? No, not really.
We'll tackle the Canadian government's inaction after hundreds of Indigenous children's bodies were found at residential schools. We'll look at how TikTok is being used to educate people about race and culture. And we'll explore how we have effectively legalized Islamophobia in Canada and Europe.
Laws that promote exclusionary politics, that say, you don't belong in our community. And that's essentially what laws like Bill 21 or laws that promote bans of certain kinds of clothing, that's what they do.
Our guests are scholars who study these issues and artists and activists leading the charge on the ground.
These amazing knowledge systems that have been experiencing epistemicide. People are all over the world involved in resurgence, reclaiming those traditions. It's so exciting.
So join us for Season 3 of Don't Call Me Resilient from The Conversation. Follow us and listen wherever you get your podcasts. Until then, I'm Neeta, and please don't call me resilient.
That's it for this week. Thank you to all the academics who've spoken to us for this episode, and to Namita Kohli in Delhi for her help too. Thanks to The Conversation's Wilder Freitas and Stephen Kahn, to Alice Mason for our social media, and to Soraya Nandi for help with our transcripts.
Find us on Twitter at TC_audio, on Instagram at theconversation.com, or email us podcast@theconversation.com. Don't forget, we've got a newsletter. Just click the link in the show notes.
The Conversation Weekly is co-produced by Mend Mariwany and me, Gemma Ware, with sound design by Eloise Stevens. Our theme music is by Neeta Sarl.
I'm Dan Reno. Thank you for listening.